I would like to welcome everybody here. I see Prince and I see Olivia. Welcome to today's presentation. My name is Farid, and I'll be your instructor for today's course, which is the IN. All right, so let's jump straight to the lesson. All right, so I'll share my screen and take it up from there. Max, can you enable screen sharing from your side? Hello. Hello, Max.
Yeah, hello, Farid. You are now the host. Sorry.
Okay. All right.
Yeah.
So let me share. All right. Okay. All right. So we'll jump straight to the intelligent network. This is the introductory course, and the objectives by the end of the course is to describe the intelligent network architecture, explain the IN concepts and principles, explain all IN interfaces and protocols, demonstrate the IN signaling flows. All right. Okay, so let's jump right in. Okay, so module 1. Can you all hear me clear, loud and clear? I want to get a feedback from my participants.
Yes, me, I hear you.
All right, all right. Okay. All right. Olivia, can you hear me?
Yes, I hear you. It's okay now.
Okay, good. Now, the IN is just an acronym for Intelligent Network. Okay, Intelligent Network. And I would like you to take mental notes or physical notes, however you want to, because there are a lot of terminologies, jargons, like which is specific to the IN network. Okay, so I might not give a full caption. I would rather be using the short versions of it because you are into the IN network. All right, so it stands for Intelligent Network. Now, why was the IN introduced? Why the Intelligent Network? Okay, so the initial digital switches like the Nortel DMS 100, Lucent 5ESS had the feature processing as part of the switch software. And if I say switch, I believe you've done the core network part of this telecom courses. So you should know what the switch is. I will not be specific to the MSC, but the MSC is also a switch. But in this sense, I'm making it generalized because before the mobile switching came, there was a fixed switch, which was an electromechanical relay switch. Okay, so when I say switch, basically the core network switch. All right. So initially, the service logic or the services were implemented on the switch itself. So aside placing a call, when you make a call, all right, the functionality, the features, everything was hosted on the switch. All right. So with time, it presented some complications, which we'll dive into as we move on. So basically, the objective of the IN is to introduce intelligence, call control, service logic of new services to the wireless or wired network without making the network infrastructure obsolete. So, I mean, it's important to understand that it has not come to replace the existing public switch telephony network, that's the PSTN. The IN is not to replace it, but rather it's been overlaid onto it. Okay, so what was done was the intelligence was taken out of the switch and placed in databases, centralized databases which we'll dive deeper into as we move along. So you know very well that the current, as it stands now, our modern day telephone user will not settle for just making calls, sending SMS, or even just browsing, right? They are yearning for a whole lot of services, maybe VPN services, which can be in the form of a family group, or maybe there's a bank who wants you to create some short codes, like abbreviated call dialing, that you can call a short number to get to the, like those services, fanciful services. Okay, that is basically what the IN does. All right, so the IN, it's more or less the node that handles this kind of intelligence, which allows the network operator to deploy a lot of services. So it even engenders competition. You see MTN rolling out some services. Maybe when you are at a particular location, your call is discounted. When you move to another location, the call is discounted. Those features and a whole lot of other wild stuff, okay, which was not possible then. I mean, implementing it on the switch itself will make the switch have a lot of issues in terms of it was very expensive, was time consuming, and it wasn't very healthy for the switch as at that time. So the IN was more or less used to deploy services. Let me put it that way. So in summary, the IN is to just, help in creating and managing value-added services in the telecom networks. All right, good. So that is basically what the IN does. So let's move on. So you can have some of the services like number portability, call transfer, abbreviated dialing, free phone, so many other services, premium rates, toll-free, closed user groups, a whole lot of services. All right, good. So the IN stands for intelligent network. So just know that the value added services have been taken away from the existing switch and then has been placed in a database which is called the SCP or the IN, and is now managed separate from the switch, more or less. All right, so that's just what the IN stands for. Okay. All right, so moving on. The intelligent network offers added value, so value addition. So we could talk of open standards, vendor independence. All right, so what was the meaning of open standards, vendor independence? Vendor independence. So prior to the mid 1960s, okay, you realize that a network operator, let's say MTN, will now go for an Ericsson switch. Okay, the switch is hardwired. The services are hardwired on the switch. Okay, so what happens is if MTN wants to deploy any new service, he has to go to Ericsson and then negotiate with Ericsson to deploy the new service that the customer is asking for, because the services have been hardwired on the switch. So he has to now go discuss with the vendor, maybe Ericsson or Huawei, and then they will now see how best they can add the new service that the vendor is, the customer is requesting for. So there was vendor dependence. Anytime you want to do a new service, which is not part of the hardwired services, you have to go and see the vendor. And worst of it, if you have two vendors, let's say you have Huawei and you have Ericsson, all of their service hardwired, it means that, when you are deploying a service, okay, people in one area who are on the Ericsson switch and people in another area who are on the Huawei switch, that they are requesting, let's say you went, Ericsson made the changes, Huawei's changes haven't been implemented. maybe due to some delays and all that. It means that one particular group of subscribers who are residing on the Ericsson switch will enjoy that service, and another group who are on the Huawei switch who are waiting for that service to be implemented will not enjoy the service. So there's like vendor dependence. You have to depend on the vendor. Okay, so with the inception of the IN, this hard wiring was taken away from the vendor, and then the service logic was now programmable. So it was now programmed and put in a separate node. So if you want to deploy a service, you don't have to now go and see the vendor who provided the switch for you. You can do your changes in-house, internally, and then you just roll it out. So it provided vendor independence. Okay, vendor independence. You don't need to depend on the vendor anymore. And then rapid service creation and deployment. So rapid, like I said, if you go and see the vendor and he's now telling you that it will take, and it was quite, it took quite a lot of longer durations to get some of these services because the thing is hardwired. You want a new service, so they have to make changes, draw calling patterns, try to put one pattern here and the other, and at the end of the day, it will drag the rollout time. So what happened was that, I mean, with the deployment of the IN, you don't have to go and see the vendor, which will now delay the whole project. You can quickly roll out your own service. So making service creation and deploying the service very, very fast. Okay, and customize services to users. So like I said, you can have maybe a company coming for some services. Let's say they want a closed user group where the staff of that company can use some short numbers to call among themselves. It's customized to that particular business. Okay, so you can customize services to specific users. All right, and then you have centralized service management. So like, again, the services are managed with the IN, which is centralized. So you take the service logic from the switch, you put it in a database, which is centralized. Okay, so you have centralized service management, and then new business opportunities by providing different different services for different needs. So the same is re-echoing the point 3. You can provide different services, different, business opportunities, new business opportunities based on different service provision. So companies can come, they want this particular service to be deployed, and then by so doing, you stay in competition because there's huge competition in the market. All right. So if a network operator is rolling out a service that will cripple your revenues, you have to react quickly because it's quite a rough market. So if MTN is deploying a service that at the end of the day, it will be juicy for a lot of people. Maybe they are making free browsing available for maybe from 6 a.m. to like 12 p.m. every day. Who doesn't like to browse free and save money? Yes, so by so doing, he's trying to cripple your customer base, and people run away from your network to MTN. All right, so you have to react. So if you don't have that service logic on your network, it means that your customers will be stolen at the end of the day. So IN helps you to be rapid in adapting to market changes and market competition. Okay, all right. So let's move on. So that's basically some of the value addition that IN offers to any network. All right. So the history and evolution of IN. So you can clearly see that 1960 we had the electromechanical relay switches. And basically, that is just switches that use electrical conduction by physical movement of the contacts parts. So you have the armature, whatever, electromagnet, springs, those kind of switches, right? These were fixed, all right? And then mid 1960s, you realize that they brought in an SPC. So SPC is just stored program controls, all right? So like I said before, the switches had the service logic hardwired. That was prior to 1960, mid 1960. And then after that, because of the challenges it presented, they now brought the stored program controllers. Okay, the stored program controllers more or less made the service logic programmable. This time over, it's not hardwired, it's programmable. So it was a step further, which now gave a little ease to the network operators, because now they don't have to go and see the vendor to now negotiate and then deploy new services. The service logics were now programmable with the SPC stored program controllers. All right. So, but in as much as it helped to understand, it still had its own challenges because it wasn't modular. What do I mean by it wasn't modular? It's more or less you could not have a service logic that can be deployed for different services. A typical example, if you are calling a toll-free number, let's say 800, okay, and then you have an SPC which is handling only 800. The service logic is on 800. If you are calling, let's say 900, it will not work because the service is just service specific. It cannot be. So if I have 800, it is a short number. That service logic, ideally, it should be able to be used for 900 short number, or any other short digit number that you can make a free phone call with. So the SPCs were more or less like modular. I mean, even though it was programmable, it was modular. It couldn't be more or less rolled out for several services at a time. It was service specific. All right. Okay, so that was around mid 1960s, and then moving on, around 1980 thereabouts. Okay, that is when the real IN concept started coming in. Okay, so with all the challenges presented by the hardwired switches and then SPCs, which wasn't that modular, was so service specific, down they came up with the proper IN. And IN was a term that was coined by Bellcore. Bellcore was more or less an telecom operator in the US. So they came up with the terminology or the term IN. Okay, and this was AIN, Advanced Intelligent Network. All right, so if you can see around the mid 1980s thereabouts, the 800 services were deployed. Okay, so 800 services basically is just doing number translation. So you call maybe EcoBank 800 0800 blah 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 blah, or you just call some short number. It will just route it to the IN. Okay, then IN will do a translation backend and then do whatever deduction, whether it's zero rating or whatever charges applied to the long number. Because at the end of the day, EcoBank will be charged, but the customer should not be charged. So you are calling 800, you will not be charged, but they have to translate the number to a long number which belongs to EcoBank, which they can apply a charge on. Okay, so that is what the 800 services basically was. That was the simple number translator service, basically the first IN service that was deployed around 1980. Okay, so we move along with different IN evolutions. IN1, IN 1 plus, IN2, AIN, release 1, blah, blah, blah. Okay, so let's move on to, we are still on the history and evolution. So I just want you to have a feel of how IN became what it is from the old switch, fixed hardwired switch system. Okay, so the term intelligent network was coined by Bell Corps in 1984. Okay, so we have these standard bodies, ITUT, International Telecommunication Union, and then under it we have the one for Europe, ETSI, and then so we have the INAP and the AIN. So you can see INAP was those two bodies which are under the global standard body ITUT had different versions of the IN concepts. So we have ETSI in the Bell Corps, which is in North America. Okay, so like I said, the Bell Corps guys were the people who introduced the term IN, intelligent network. Okay, all right. So, but just a preamble, IN being an intelligent network doesn't mean that since the intelligence is taken away from the switch doesn't have intelligence. I'm sure you've already done some of the core network concepts, and you can see it's quite a lot of abstract stuff. It's very, very intelligent. The intelligence in this sense is relevant in terms of something that is directly applicable to the customer. So the services that the customer wants to enjoy, you see. So the intelligent part of it, how to deploy services, that is what the IN is handling. So not as though once the IN is the intelligent network or the only intelligent network in a network, a telephony system. No, it's just intelligent network for service deployments. Okay, all right. So IN1 was introduced by Bell Corps after the initial IN having SCP only as a simple number translator. So different features were added, new functionalities as it moved on, and so for more switch independence, rapid deployment of new services. Okay, so moving on, we can see that further releases and upgraded versions of the IN, including European equivalents of the AIN, were made possible using the concept of capability sets. So please take notes of some of these terms, capability sets. Okay, so the IN evolution were made possible with the concept of capability sets. So capability sets are made up of service independent building blocks called the SIBs, SIBs, service independent building blocks. So you can be taking note of some of these.
Hello, Farid, please.
Yeah.
Sorry to interrupt. Could you please share the slideshow? Click on the slideshow so that it will become bigger.
It will become bigger. All right.
Yes.
But are you hearing me clear, loud and clear?
Yes, we are hearing you loud and clear.
Okay. Yeah. So right. Is it okay now? I've made it slideshow.
Yes, now it's okay.
Okay.
All right.
All right. So, all right. Thank you. The service independent building blocks. All right. So capability sets, like I said, it's what is used to add new features to the IN. So if you want to move from IN version 1 to IN version 2 to IN version 3, or like new versions of new phases of the IN, the concept of capability sets was introduced, and the capability sets are made up of SIBs, service independent building blocks. Please take note of these terminologies. All right. So these SIBs basically handles IN service functional entities. So basically, what these SIBs does, these SIBs, the service logic, okay, these SIBs had the service logics, and then the service logic more or less were like programmable. Okay, so you have a service triggered to the IN, and then there will be an interpreter to interpret the service logics. All right, so these are all programs that the capability sets basically were just programs, simple programs that were interpreted on the IN. Okay, so just take note of that. And then, so capability set 1 was released in 1993, set 2, 1997, set 3, 1989. So you can see the evolution. And then the set 1 specified basic IN concept and modeling. All right, set 2 specifies management interfaces, core unrelated switching functions, and then focuses on mobility management. All right, so if you see set 3, capability set 3 focused on mobility management. So this is where we now had mobile telephony. Okay, so the IN was now with capability set 3. That is even our focus in the course of as we move along, because we'll be talking of a protocol that is relevant to mobile telephony, modern day use. Okay, so GSM 2 plus, and then 3 integration and interoperability of IN. Okay, so let's move on. Okay, so how is intelligence provided and distributed in the network? All right, so they came up with the same ITUT, the standards body. ITUT came up with the IN conceptual model. IN conceptual model. So IN conceptual model gives a framework for defining the basic building blocks and service functionalities. So we all know what the model is. So you have if you want to design a plane, you get a toy plane, or the architects, they can have a prototype of whatever building they want at the end of the day. But that one is even more is more relevant in terms of appreciating it, because you can see the model, which is exactly the same as the building that they are going to build. But this one is abstract. Okay, it's quite abstract. So the IN conceptual model is an abstract model, which will help us to understand the stages from the physical node all the way to when a service is deployed. So it's no surprise that the IN conceptual model was designed by ITUT, because they are the same people who designed the OSI model. And as we all know, the OSI model is also the same concept, okay, which define functionalities and standards between computer networks or communication networks, so that they can communicate among themselves. All right, so the OSI model, as we all know, is from a physical layer all the way to the application layer. So we have intermediary layers, the data link, network, transport, session, presentation, all the way to application, like those 7 layers. So it starts from physical to application. Now, the IN conceptual model is the same thing. So we have a physical layer or plane all the way to service plane. So you can draw an analogy here. The same as the OSI model. So physical will have to do with the tangible network elements. So you have your routers, your whatever, you can, the switches itself, they are tangible, the network cables and all that. Okay, now the application at the end of the day, whatever service it's being deployed is at the top of the hierarchy. So in between is where the abstraction is. Then you see a whole lot of abstract stuff, data link, network, transport, session, blah, 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 very, very abstract. So when you collapse it from the physical to the top, you just collapse it. It collapses from physical to application straight up. Okay, so we just want to get to the application, but we have to climb all those stairs to get there. The same thing with IN conceptual model. So this is just a planar concept. It's involved planes. Okay. So just see it as a direct analogy to the OSI model. Okay. So the model is an abstract representation that provides a common framework for vendors and service providers, thereby giving IN architects and implementers a common terminology base for discussion and allowing the development of modular network components. So it helps IN architects all over the world to talk, to communicate. That's their field, you see. So they have their own, there's a jargon that they can use to work with. Okay, so basically that's the IN conceptual model. It was used to distribute intelligence in the network. So let's go straight to the model, how the model is interpreted and what makes up the model. Okay, so we have, like I said, the physical plane all the way to the service plane. So in between is just two planes, the distributed functional plane and the global functional plane. So the physical plane is hosting the physical elements. We have the SSP, okay, so the service switching point. In the mobile telephony, let's say the GSM networks, you can call it the MSC. But I'm not really restricting it to only mobile telephony. So just stick to the SSP. All right, we have the intelligent peripheral, the IP. This is not internet protocol. Please take note of this. So if you see me using IP in relation to the IN network, just know that I'm talking of the intelligent peripheral, not internet protocol. Okay, and then we have the service creation environment. So with most of the vendors, they provide user interfaces, okay, web portals that you can use to create services. Okay, so you have normal machines that you can just log in based on the interfaces that you have access to. You can just go in the portals, buttons, click, create this service, just taps and just you are done creating. So it's also part of the physical plane. Then the SCP itself. So when you talk of IN and you don't talk of SCP, then you've not spoken about IN. The core of the IN is the SCP. Every vendor has an SCP, as far as I'm concerned. From Huawei to Alcatel to Ericsson, SCP is just the heart or the engine of the IN. So it's called a service control point. Service control point. So, I mean, the vendors have different evolutions of their IN systems, where the SCP now branch out into several other based on the way they want to build their system. But the SCP is always there in every IN system that you can find in the world. Okay, so that is that for the physical plane. And then going to the distributed functional plane, we have the service switching function. So it's a functional plane. Okay, it's a functional plane. So what function is the physical plane performing? So if you look at the SSP, the round box, sorry, the round box. So you see call control function, service switching function. Okay, and then for intelligent peripheral, you see specialized resource function. Okay, then service creation function belonging to the service creation environment. Then the pyramid, the hosting the SCP, you will see it pointing to a service control function under the distributed functional plane. Okay, so the functions that they perform, what function does the SSP perform? What function does the IP perform? What function does the service creation environment perform? What function does the SCP perform? Basically, that is that, as simple as that. And then we move to the global functional plane. So the global functional plane is the one that hosts, the plane that hosts the SIPs that we spoke about. Okay, like I said initially, that the capability sets that is used to define the progression of the IN into phases. okay, is made up of the service independent blocks. Okay, so the SIPs is found in the global functional plane. So the SIPs are just programs which are interpreted. Okay, they are just programs. So you will see that the specialized resource function has the user interaction program or the user interaction SIP. What does that mean? User interaction. So if you relate it from the global functional plane all the way to the node, physical node itself, the IP is what plays announcements for or for the customer, IN announcements. So for example, maybe you